Hello, welcome to tutorial 2 of Multiphase system. So in this tutorial 2, we will solve questions relating to solutions of solids in liquid. So this question is actually from your textbook, example 6.5-2 in this chapter. Okay, let's look. These questions actually will show you how we use solubility to solve problems relating to crystallization. Okay, let's look. Let's look at the question. So we have an aqueous. So when it's aqueous, that means it has water. An aqueous potassium nitrate solution containing 60% potassium nitrate at 80 degrees C is fed to a cooling crystallizer in which temperature is reduced to 40 degrees C. So we have a crystallizer which operates, which have inlet of 180 degrees C and outlet 40 degrees C. This is what it meant. Okay, so the question wants us to find the temperature at which the solution reaches saturation. Second, to determine the percentage of potassium nitrate in feed that form crystals. So let us translate this question into our process flow diagram. So let's take a basis. This is our process flow diagram. So let's take a basis of 1000 gram of potassium nitrate solution at inlet. So we draw our process flow diagram. So crystallizer, we have crystallizer, cooling crystallizer, right? As the question said. So we have inlet of potassium nitrate with 60% potassium nitrate and 40% water. So when we translate into this information, it becomes 600 gram potassium nitrate and 400 gram of water from this one inlet of 1000 gram potassium nitrate solution. And it goes into crystallizer at 80 degrees C. And the cooling crystallizer, it reduces the temperature from 80 degrees C to 40 degrees C. And when a solution goes into crystallizer, so we expect to have a mixture of solid and solution, which this solution contains still solid, the same solid with water. Okay, so the outlet of crystallizer for crystalline obviously contain the solid crystals and also the solution of the solid. Okay, so this is M1 feed the outlet M1 in terms of solution and also M2, and the solution contains solid X1 and also 1 minus X1, the liquid, this water. The 400 gram of water will go here. Alright, so this is how crystallizer outlet looks like. But sometimes you may see they use crystallizer fast dryer, but crystallizer press dryer, so you will see two lines. But if it's just crystallizer, normally it has one line unless it's mentioned otherwise in your question. Okay, right, so the first question for these problems, it wants us to determine the temperature at which the solution reaches saturation. Which solution is mentioned, it says. So definitely it refers to the solution, the inlet solution, the feed. Okay, this feed we do not know whether it's saturated or not saturated. So since we are given the mass fraction, we definitely can check what will be what is the solubility of the inlet solution. Remember from our part 6 where we change mass fraction into solution. Let's check what will be the the solubility of this solution. So let's check the solubility because we have the mass fraction. So we know solubility is solute divided by liquid. So 600 gram potassium nitrate we have divided by 400 gram of water. So we have 1.5 gram of the solid per water. So we translate this into solubility data because we have to divide by 100 H2o for solubility. If we have that data, then we can use this figure in your textbook the solubility figure in your textbook. So to convert this, we have 2 times by 100. So we times both top and bottom with 100. So we'll get the solubility of this inlet solution is 150 gram potassium nitrate per 100 gram of water. This solubility data correlates, actually this solubility actually correlates to 74 degrees. So it correlates to 74 degrees. So it will be saturated if you have this much of salt in water. It actually saturated at 74 degrees Celsius. But we look at the operating it is 80 degrees C. That's why we do not have any solid yet, because it's 80 degrees C. The solubility is higher. This one actually solubilized at 70. You start to become saturated at 74, but at 80 degrees C it is still not saturated. That's why it is still in a solution. You have potassium nitrate, potassium nitrate in water, solubilized in water, because it start only to be saturated at it is saturated at 74 for this much, because this 80 degrees C require higher solubility. Okay, so now for this, actually it becomes saturated at 74. So why is it important? Because we 74, this will start to have some crystals, particle. It is saturated. So if we cool it a little bit more, so we look at the we look at the outlet. So it is being cooled to 40. Definitely we have too much of solute for 40 degrees C, right? Because 40 degrees C solubility is lower. So 74 at 74 solubility is higher, means you have higher salt, you have higher potassium nitrate. When you reduce the system into 40 degrees C, so this 40 degrees C has lower solubility for potassium nitrate. So you will start to have at your outlet some potassium nitrate becomes solid, some will remain in terms of a solution. Okay, that's why we have these two outlet here. Okay, let's go. So for this solution, it reaches saturation at 74. So we have answered for section 1. So we are going to look at section 2. We need to determine the percentage of potassium nitrate in feed that becomes crystals. Question 2. Determine the percentage of potassium nitrate in feed that forms crystals after cooling. Okay, so actually we need to determine M2. So if we look at, we have 3 unknowns. We have only 2 equations. So definitely we cannot solve it. But we cannot solve this mass balance because we have more unknowns than the knowns. Okay, how we're going to do this? We can actually solve for x1 if we have the data for solubility. And if you refer to textbook, we actually have table 6.5-1 solubility for potassium nitrate. So let's find this x1 from this table. Okay, so to solve it, if we have this, then the mass balance, the finding M2 and M1 is easy. But the trick is, we need to find x1 first, because we know the temperature for this potassium nitrate solution solubility. So let's determine x1 first. So x1 can be determined by converting solubility data at 40 degrees C to mass fraction. This is we'll learn before, right? So we look into figure 6.5-1 from your textbook. So we obtain solubility of potassium nitrate solution at potassium nitrate at 40 degrees C is 63 gram potassium nitrate per 100 gram of H2O. Okay, look at 40 degrees C and then look at your solubility. So you'll get this number. So from here, you convert it into mass fraction x1. Okay, 63 divided by the total mass of the system, 63 gram per 100. Then you obtain your mass fraction for X1, that is for potassium nitrate, that is 0.39 gram potassium nitrate per gram. Okay, now you obtain your X1. So now to solve M1 and M2 is easy. So we obtained X1 just now. X1 equals to 0.39 gram potassium nitrate per gram. So to solve for M2, the easiest way is to start with H2o balance, because H2o only involve these two. So H2o balance, we know H2o in is 400 gram equals to 1 minus X1 times by M1 that you get for water. Okay, so so from this equation you'll get the mass for potassium nitrate solution. Okay, so mass of potassium nitrate in total is 655.74 gram M1. This solution contains water and some solid. Okay, some solid. Right, so for M2, we just do overall balance, so we'll obtain M2 equivalent to 344.26 gram of potassium nitrate crystals, that we obtain from this process. So initially we have 300 gram of potassium nitrate, 344.26. When we cool at 344.26 become crystals. When we cool this solution from 80 degrees C to 40 degrees C. If we cool it at 74, we just have very small solid. But if we reduce the temperature more, we'll have more potassium crystals. If actually this process being reduced to 20 degrees C, we will expect more potassium crystals to be formed. Okay, so the minimum temperature that you use to make it into crystals is 74 degrees C. So I hope you understand the concept. Please study example 6.5-1 and also 6.5-3 to further understand the concept of solution of solids in liquid. Thank you.